Okay, here we have just 1/4 of the unit circle. This is in quadrant 1.
You made me choke.
So we take the coordinates we had over here, and what's the coordinates right here at the bottom, right left, bottom left? What's
0, 0.
So we got 0, 0 down here at the origin. What about over here on the right?
1, 0.
1, 0. How many degrees is that on a circle?
0.
It's 0 degrees, right?
0 degrees.
So we'll put 0 degrees. I'll put it here just like that, 0 degrees. What about at the top of the circle? What's the coordinate?
90 degrees.
It's going to be 90 degrees.
And it's going to be 0, 1.
And it's going to be 0, 1 as a coordinate. Right? So we have that. Now, what you have to know on a unit circle is the x values are the cosine of what's on the unit circle. The y values are the...
10.
No.
The
X is
tangent.
cosine, y is
Sine.
sine. So sine is going to be our y value. So I'll say sine equals y, cosine equals x. All right, now as we go around the unit circle, do you remember from what we talked about earlier and what we see around us? If we change this 90 degrees to radians, what measure of angle are we going to have?
Pi radians.
Pi radians?
Pi over 2 radians.
Pi over 2 radians. So let's go ahead and mark pi over 2 radians, and I'm going to go ahead and mark it in blue. So we have pi over 2 radians. So we have a radians equivalent. So we're going to be filling out the first quadrant of our unit circle today. Now, we're going to talk about these other angles, and I'll just write them down here. 60 degrees. What is going to be the measure of 60 degrees in radians?
Pi over 3.
Pi over 3. All right. And if you take that, what we did earlier, right, you...
Wow.
Y?
Yeah.
Okay, let's talk about it. It's a good question. Remember we had 60 degrees. How do we convert from degrees to radians?
I don't know.
You have to multiply times pi 180.
We multiply times pi radians over 180 degrees.
So, multiply times 3.14. And what
No,
is?
no.
And 60 going to 183 times.
He said 3.14.
What?
No, we want the answer in pi.
3.14, what you're doing in mathematical language, you don't change the symbol of pi into a number unless you have to. If you convert back to degrees, you have to.
Antonio?
But degrees over degrees do what?
Cancel.
Cancel. So what do we have left?
Pi.
Pi. We have
Times.
we have 1/3 pi radians. So hence pi over 3. Okay, that's in radians. And in radians, we usually just have pi as part of the symbol. Next, 45 degrees. What's 45 degrees going to be? 45 degrees.
Four.
That's going
Four.
Power
Yeah,
four.
5 over 4.
Okay.
And finally, we have 30 degrees.
Geographers in here?
Power 6. Power 2. I mean,
Right here.
Mr. Johnson is right. Thank you, Mr. Johnson. Pi over 6.
Thank you, Mr. Joe. Oh, Crystal.
hold on. Can you explain that, Mr. Jordan?
All right, let's go ahead.
Oh, you were playing?
This one.
Don't play with me like that.
Okay, we got 30. Okay, this is 30 degrees. What do we do to change 30 degrees into radians, Mr. Haley?
I don't care.
Thank you, Mr. Joe.
Oh,
Okay, we multiply times pi
okay. I said
radians over 180 degrees.
Hey, we could leave. Or we take the group, so.
And so we're ends up being 1/6 pi. All right. Now,
to be there.
I'm going to erase this, all right? We're going to find,
March 8, 2012, through March 20, 2012.
Mr. Johnson, siege. All right, all the radius here, what is the radius of our unit circle? 1. And when we talk about a hypotenuse of every triangle that we're going to make out of every coordinate on the unit circle, what's going to be the hypotenuse?
The inside, the top.
What's going to be the distance of the hypotenuse?
The pi. 1.
It's going to be 1. All these hypotenuses are 1 in length. Right, they're all 1 in length. Okay,
They don't have no spring break.
now, let's go to,
That's what I'm not gonna.
we go to these points. We don't have to remember a lot in math and in algebra, but the few things we have to remember, we have to understand and remember very well. And this is one of those things. We're going to find the coordinates for these, and we can develop them from special right triangles, and I think we have earlier, if you go through your notes, we have developed the sides from 30, 60, 90 right triangles and also 45, 45, 90. So we've done this. What is going to be, we set these up as fractions, all these up as fractions. What's going to be in the denominator of these fractions, do you think? Every one of them. 2. Mr. Johnson, were you in 5th period today? Good job. Now, we have to remember, and there are different tricks. There's a hand trick, there are songs, we might do a song later, but the way that makes sense to me, that I can remember easiest, is if you start on the sine side. By the way, remember it's cosine sine, xy, cosine sine, cosine sine, right? You start out with, here, the sine is, for 30 degrees, 1/2. So you put 1 here, and then you go up to the next one, sine 45 degrees, or sine pi over 4, and you put square root of 2. And at the very top, the sine of pi over 3, you put square root of 3. So it progresses from 1, square root of 2, square root of 3. You can think of it as square root of 1, square root of 2, square root of 3. And now you're at the top. What do you think the cosine is going to be here?
1.
Why do you know it's 1? You're exactly right.
Cause it's gonna go 1.
I don't know, I just guessed.
Okay, well, it's an intelligent guess. And what it is, you have a 30-60 triangle here, right? Are 30 and 60 triangles related? Are they related? They're very much related. So this 30-degree angle here becomes a 30-degree angle here.
Well, I think I know, and the next one's going to be square root of 2, and then it's going to be square root of 3.
Gotcha.
And so it's easy to remember, but it's good if you did like Miss Kemp to just kind of think your way through it. These are things you have to remember and just know them cold. Now there's one more thing that I like to add to it, and the reason I like to add, you don't see this on the unit circle, I like to do one more thing, and that's put decimal equivalents here. Why do I like to suggest putting decimal equivalents for
More
coordinates?
accurate.
No, the reason is, whenever you go on a calculator and you calculate something, a sine, you're going to get a value that's not, square root of 3 over 2 is not going to show up like this as square root of 3 over 2 on your calculator. It's going to show up as a decimal. And so having these decimals on your unit chart helps you think and remember what those decimals are going to look like. So when you make that calculation and you see that number for sine or cosine, you'll know what they're talking, you'll know what it really is, right? So the decimal equivalent of 1/2 is 0.5. And then we also know up here the cosine of pi over 3 is also 1/2. Now the cosine of square root of 3 over 2, or excuse me, cosine of pi over 6 is going to be square root of 3 over 2. And if you put that in your calculator, you're going to get approximately 0.867. It might be 0.866, so on. And then over here it's going to be 0.867 also. And then square root of 2 over 2. Has anybody put that in your calculator yet? Square root of 2 over 2?
0.707.
Yeah, so 0.707 And you know also that the sine is going to be 0.707. And these ones, besides the 1/2, I put 1/2 here, I meant to put 0.5. Besides the 1/2, these are just decimal approximations, right? Because they're just rounded off.
Chill.
But just become familiar with this, and if you understand this, what you're able to do is you're able to go over to 120 degrees, or 2 pi over 3, and you'll be able to find. Now, as you go to quadrant 2, here you have, on the quadrant 1, you have sine, the cosine is positive, sine is positive. When you get to quadrant 2, what changes? What signs change?
Oh, it could be negative.
Yeah, over here, on
It's gonna be
quadrant 2, you have
negative,
negative, positive, and then quadrant 3, you have
Negative, negative.
negative, negative, and quadrant 4, you have
Positive.
positive, comma, negative. So these are things, these signs help you realize where on the unit circle you are. So this is an introduction, and we're going to go into the unit circle. I'm going to hand out a diagram for you shortly. Do you have any questions about the development of this so far? I want to thank the class. You've been a good audience today. Thanks very much.